Okay, well, this lecture, as promised, I'm going to do a review for the second exam, which is coming up next week. But hey, let's get to the board. Let's talk about a couple other things that are happening this week, and then we'll get into the review. Okay? Remember, you have your second homework assignment due. It's on due Friday, October 13th. That's at midnight. And I know that the first homework assignment, not a lot of you did it because we had the hurricane issues and everybody got points for it. But what you're going to do is you're going to create a Word file with your answers. If you use a statistics software to generate one of the answers, then you're going to include the printout in with your answers and submit that through the link, through the Homework 2 link on Canvas, the assignments for Homework 2 link on Canvas, no later than Friday, October 13th. Then sometime over the weekend, I'll go ahead and post the answers to help you study for the second test. Okay, so that's Homework 2. And then remember, your other assignment is to generate printouts that you're going to bring in with you to the second exam. 5 statistics printouts you need to generate with you. And remember, it's going to be based on a data set that I have you pick, one of 4 data sets. I'm going to show you that here in a second. But to help you with doing this, if you need help, the TAs that are normally in the stat lab will be moving at various times to the CIS 1034, 1035 computer labs. Okay, what are those various times? You take a look on Canvas, the schedule's posted. I'm going to switch over to the computer now and show you that. Just take a look here on Canvas. These times are posted where the TAs are moving from the stat lab into the CIS, either 1034 or 1035 computer lab, to give you help. And remember now, on the times that they're not in the computer lab, they'll be in the normal stat lab. So the stat lab's not closing. It's just moving at various times. So if you need one-on-one help with that, that's great. Also remember that I did a demonstration on how to generate these 5 printouts on Lecture 9. Lecture number 9, there's a little demo on that. So you should be able to follow that pretty easily. But just to remind you, let's go show you what you need to do. Okay, here are the 5 printouts you need to generate. First is simply a listing of the data. Remember, this is a simple linear regression problem. The second one is the scatter plot of the data. The third one, the correlation between the 2 variables. The fourth one is simply a simple linear regression analysis. And finally, prediction of confidence intervals where you pick the value of x. And you're going to generate these 5 printouts based on selecting one of these 4 data sets, one of these 4. Okay, any one you want, it's okay with me. Legal advertising is on page 617, PGA data set on 632. There's a tweeting data set on page 633, and a GMAC data set on page 669. By the way, heads up, those of you that picked the GMAC data set, there's a lot of observations there. That's no problem. But there's over 2,000 observations. When you print out your first printout number 1, you just simply need to list the first 50. Okay, you don't have to give me like a 10-page listing of all your data, because we know how big that is. So just keep that in mind. Now I'm going to show you these printouts a little bit later in this review, and we'll go over each one as to what they mean. But this is what you have to do. You have to generate the 5 printouts. And remember, these need to be clean printouts. These need to be clean printouts. Well, let me remind you about the second exam on when it is and what you're going to be doing. All right, so the second exam next week, October 18th and 19th. That's a Wednesday or a Thursday. Remember, you need to come to your regularly scheduled classroom and class time. And what's it going to cover? Well, Chapter 11 is the simple linear regression chapter. And then the first 6 sections out of Chapter 12, which is multiple regression. Everything here corresponds to lectures 7 through 11. And then if you count this 12th lecture, this review, 7 through 12. So lectures 7 through 12. You're bringing in a picture ID like you did on the first test. No cell phones, calculators permitted. You won't need to do any calculations, or they'll be very, very minor, and you won't lose for math errors. But in addition, you will be bringing in your 5 printouts with you. Now, I say clean printouts there. That means this. No highlighting, no writing, no marking on those printouts of any type. And make sure you don't do that during the exam also. So they come in clean, they go out clean. And now, of course, you put your name on there. You can number them. That's fine. But other than that, keep them blank. You'll be referring to those during the exam. Now, that's next week. Let's review for this test. What I'm going to do is, now normally I do a review of the previous lecture, and I'm going to do that, but I'm kind of embedding it in this review for the second exam, kind of killing 2 birds with 1 stone. Okay? All right, like we just said, this exam covers the 2 chapters. One is the simple linear regression chapter. Oops. One is simple linear regression, and the other one is the multiple regression chapter, Chapter 11, Chapter 12. So I broke up this review according to the models that we've covered in those 2 chapters. All right, so we're going to go over each one of the models that we covered to help you. The simple linear regression model is a simple one. That's why we call it simple linear regression. It has just one independent variable. Remember the whole idea of regression. Trying to predict the value of a dependent variable y based on the values of independent variables x's. There's only one independent variable in this model, hence simple. And then linear comes from the fact that this model proposes a straight line relationship. So there's a graph of this model, a straight line relationship, y on the vertical axis, x on the horizontal axis. Now, what I want to do here is also show you what tests you might want to perform, what are the important beta interpretations to make. Here, the beta that's multiplied by x, that's the slope of the line. The other beta is the y-intercept. The slope of the line is the one that has the practical interpretation. Okay, so, and we're going to go over that when we do the sample test. But that's the important beta to interpret. And it's also the important beta to test whether or not there's really a linear relationship between the 2 variables. So we conduct a t-test on that beta. And then, remember, there's also some model-based statistics that help you evaluate the model even further from a practical standpoint. And in simple linear regression, we talked about 3 of those: the R-squared statistic, twice the standard deviation, and also the correlation coefficient. And then we also learned that the correlation coefficient really was redundant, that we really didn't need that as part of the game plan for simple linear regression because all the information in R is already contained in beta 1. So beta 1 already has all that information, and if we analyze beta 1, we're good. So that's just an overview of that model, okay? We'll get into more details when we go over the practice test. All right, then we move to multiple regression. Whoops. And we looked at 2 models in multiple regression. The first one was what I called the first order model, a first order model, and here it is. Now there are multiple x's. By the way, all these x's are quantitative in nature. Here we just looked at 2. Okay? It's called first order because you just raise each x to the first power. That's where the 1 is coming from in first order. Just each x is raised to the first power. And that's it's really a basic just extension of the simple linear regression model. And of course, in simple linear regression, we had slopes. We had a slope coefficient. Here, multiple regression, there are 2 slopes. And why do I say 2 slopes? Because there are 2 x's. 2 independent variables, 2 slopes. So you might be interested in looking at the relationship between y and x1. Remember our practical example, we were modeling y as the price of a grandfather clock sold at an auction, based on x1, the age of the clock. Somebody did ask me in the newspapers, how do I know that age is x1? And remember also in this case, x2 was number of bidders. I know it because we picked that to be the case. We picked x1 to be age. We picked x2 to be number of bidders. Okay? Now maybe the question should have been, how do I know what the slope is involving x1? Maybe that's a better question. Okay, well that's an easy one to answer actually. If you're focusing in on the relationship between y and x1, like I'm doing there in the circle, look to see what beta is multiplied by x1. Oh, that's beta 1. Therefore, beta 1 is the slope. Okay? And that's just an extension of this simple linear regression model. Now, if I want to change gears, and I now want to focus on the relationship between y and x2, now I'm looking for the slope of that line. Well, what's it going to be? The beta that's multiplied by x2. Now, I also showed you in these graphs that you had to hold the other x fixed to draw the picture. And so, for example, in the one on the left, x1 is age, and we're modeling that. So we have to hold the other x2 number of bidders fixed. So whether we hold it x2 fixed at 5 or 10 or 15 or 7 or 9 or whatever, it doesn't matter, you get the same slope. You get parallel lines. And likewise, on the other case, when you're modeling y against x2, okay, you have to hold x1 fixed. That's the age of the clock, 100-year-old, 95-year-old clock, 150-year-old clock, 200-year-old clock, whatever. Again, that's not going to change the slopes. That's one feature of this model. Good or bad, but that's a feature of the model, and we have to understand that. Okay? Then what are the tests you perform? Now, instead of doing a t-test on one beta, it's better to do a global f-test on all the betas simultaneously equal to 0. Remember, we talked about the global f-test being the key test to perform in a multiple regression. And as far as model statistics go, we no longer need the correlation coefficient because that only pertains to simple linear regression. Still focus in on the 2S for practical interpretation. And again, we're going to go over that interpretation in the sample test. But now we switch gears, and instead of looking at R squared, we look at adjusted R squared, because we don't want to artificially inflate the R squared value by adding too many x's to the model. And so we look at the adjusted R squared, which is a more conservative estimate. And those help us get at the practical utility of the model. And I've emphasized in class several times that when it comes to model-based statistics, they're nice because their interpretations never change. But when it comes to slopes, those interpretations could be different depending on the model. All right, so we looked at that model. Then the last model we looked at, and this is kind of reviewing last lecture too, was the interaction model. And notice in this model that beta 3 term gets added. And that term is just a cross product of the two x's. When you multiply two x's together in a regression analysis, that's given a special name. It's called interaction. It's called interaction. And that implies that the relationship between y and one of those x's depends on the other x. So when I draw these graphs now, so let's focus in on this one right here. When I draw these graphs now it matters what I hold the other x fixed at. And the slope is no longer just the beta multiplied by this x. So let's ask this question again that somebody asked me in the minute papers. All right, now we're focusing on, say, the relationship between price, y, and x1 age, because that's the graph I'm circling. And I want to know what the slope of that line is. Well, it's not just the beta multiplied by x1. It's any beta multiplied by x1, and there's a couple of betas in there multiplied by x1. Beta 1 is multiplied by x1, and so is beta 3 times x2. So the slope now is beta 1 plus beta 3 times x2. It's more betas are involved in the slope. And you can see that that slope depends on x2. So if you change the value of x2, you're going to change the slope. That's why the picture shows you two non-parallel lines. One for x2 equal to 10, one for x2 equal to 5. Same thing's going to happen when you focus in on the relationship between y and x2. That's the number of bitters. How do I know what the slope is of the relationship between y and x2? Go find any beta multiplied by x2. That's beta 2 as well as beta 3 times x1. So you have to add those up. And you can see that that slope depends on x1. So if you change the age of the clock, 150, 100-year-old, 95-year-old, 200-year-old, whatever, you're going to get a different slope. So maybe you memorize what the slopes are, but you know what? You don't have to. You really don't have to. If you just use common sense and think, and I'll go back to simple linear regression, okay? If you ever get stuck, think simple linear regression. If I ask you what the slope of that line is, you all know it's beta 1. And notice that beta 1 is multiplied by x. So if I ask you what's the slope of the line relating y to x, it's the beta that's multiplied by that x. Okay, that's easy. You go to multiple regression first order. And if I ask you what is the slope of the line relating y to x2, it's the beta multiplied by x2. Okay, that's beta 2. And now when you go to the interaction model, and again I'll ask you, what's the slope of the line relating y to x2? It's any beta multiplied by x2. Just like before, there's more betas though. Beta 2 is multiplied by x2, so is beta 3 times x1. That's why the slope's more complex. So that's kind of an easy way to figure out what the slope is. Now as far as the tests go, global F test, always the case, always an important test to do, test the statistical adequacy of the model. And of course that involves an extra beta now, beta 1, beta 2, and beta 3 simultaneously equal to 0. And then also, because we have this more complex term, now a t-test on that more complex term makes sense to do. Because we want to know, do we have interaction or don't we? It's an important question, so we want to test that also. Model stats are the same. R squared, adjusted, twice the standard deviation to help us evaluate the model. They're the same. Okay? So those are the three models that we've covered. And that's what you're responsible for on the test. Now about half the test, roughly half the test will be on the first simple linear regression model, because that's the one where you're doing the printouts for. And then the other half of the test will be on the multiple regression. Now before we go on to that, remember that for all these models, you have assumptions that you have to make about the random error term. And there they are. Mean error equal to 0, variance error constant, error is normally distributed, error is independent. Maybe to help you remember, you can remember this little notation. or if this doesn't help you, then just ignore what I'm saying right now. But that little notation is what statisticians use to help remind them what the assumptions are. That means that the error term has the following distribution. The capital N means normally distributed. That's where that's coming from. The 0 means mean is 0. The sigma squared means variance sigma squared. And one of the i's means independent. So that might help you. If it doesn't, don't worry about it. Just remember the 4 assumptions. Now, we're not checking any of these yet. We will, but that would be important to check them. There were some minute paper questions that I want to cover. I kind of already did the first one. Okay, which betas are the slopes? Okay, we went over that. But there was another one that somebody asked me. I've embedded a lot of the minute paper questions in the review without saying that. But here's another one that stood out, because some of you looked at your printouts, your statistics printouts, and we're going to go over them in a second here. Some of you looked at your statistics printouts, and you see this crazy notation on one of the numbers, like an E with a minus sign or an E with a plus sign. That's called exponential notation. Exponential notation. That's simply a way for the software to present the value, the result, for a number that's either too small to fit in the right number of space available or too big to fit in the amount of space available. And so it changes to what is called exponential notation. So if you ever see a capital E on any one of your printouts, then here's how you interpret it. If you see an E followed by a minus sign, like that one right there, what that tells you is you're going to move the decimal. Anytime you see an E, you're going to move the decimal. The minus sign tells you to move it to the left. In other words, make the number smaller. The other case, the positive sign, tells you to move it to the right, make the number bigger. And then the number that follows the plus or the minus tells you how many digits to move it. So for example, on the one in blue, 2.7e minus 03, says move the decimal 3 places to the left. When you do that, you get that small number 0.0027. The other one, 2.7e plus 02, says move it 2 digits to the right. And that gives you a bigger number, 270. So that's how you interpret the E notation, if you see it on one of your printouts. Okay? Don't get confused by that. All right, now a couple other things to help you. All right. There's a guide to regression. I pointed this out to you actually maybe last lecture or the lecture before. And it's on the textbook. It's on page 782. Let's take a look at it. It's a nice flow chart that I think will kind of give you a really good overview of what regression is all about. Okay? So if you look at this flow chart, again, page 782, there's some questions here that are more appropriate for what we're going to cover a little bit later. Okay? But right now, you have 1 or 2 variables that you're responsible for, okay? And then you're going to hypothesize a model for that relationship. Whether you think it's straight line or whether you think it's interaction or independent, whatever. So you hypothesize the model, and then you can evaluate the model from a statistical standpoint, okay? Conduct an F test, conduct T tests, okay? Then you're going to, now, we're going to check these assumptions. You just list them right now, but we're actually going to check them a little bit later, and then we're going to maybe make some modifications. You don't have to do that yet, but then we're back over here. Then you're going to assess the adequacy of the model, global F test, check the practical utility of the model, the R squared adjusted, the standard deviation, okay? And then if you're satisfied, if the model is adequate, you're going to go ahead and use it for the last step for prediction purposes. And if you're not satisfied, notice the arrow says, I'll move it over a little bit, go back and re-hypothesize, look at a new model. So that's kind of like the overall, the big picture view of a regression analysis. Of course, the details are important, and that's what we're practicing now. All right, so that's that. I wanted to show you that. All right, now I want us to take a look at the 5 printouts that you're going to generate for the exam, because there's some important things to come on each one of those. Now, some sample printouts are given to you in Canvas. If you go to the Canvas modules section and cursor down to where it has sample printouts for exam 2, I'm going to show you those. These aren't what you're generating though, okay? None of this sample set of printouts, I'm calling them Terry's printouts for exam 2, okay? None of these are going to be any one of the 4, okay? Because I want to be fair here. I don't want some student to think like, well, I'm just going to pick Dr. Sinchik's sample printouts because I don't have to do anything then. No, you have to generate your own printouts. They're going to look like this, but they're on different data sets, okay? And by the way, there's a nice warning telling you when you go get the sample printouts, please do not use these, please do not bring these to class for the exam, because you'll lose a lot of points. You don't want to do that. Okay, but anyway, to give you an idea of what you're going to be looking for. Okay, in the first printout, the one that simply is a spreadsheet data listing, and all I did was just call it printout number 1. Okay, the main thing you're going to look for here is figure out which one your independent variable is. What's your x? And then look at the range of that x. Now, why am I focusing on the range of that x? For example, in this case, I wanted to model price y as a function of age. This was the grandfather clock example. Price of a grandfather clock sold at auction, age of that grandfather clock. Why do I care about the range of age? Why is that important? Well, let's find the smallest one first. I think it's 111 if I'm not, or maybe it's 108. Smallest one, there it is, 108. That's the smallest one. The biggest one I think is 194. That one right there. Why do I care about those numbers? Because a little bit later on, if I'm going to use this model for prediction purposes, don't I want to make sure I pick a value of age that is inside the range of the sample data? I don't want to pick a value of age that's outside that range. So how do I know what that range is unless I go find it? And so that's one thing that will help you, okay, in picking a value of your x for the last printout, making sure you don't pick a value of that x that's outside the range. So that's why it's important to look for those numbers, okay? Then we go to the second printout, which is simply a scatter plot of the data. Make sure you have the software include the best fitting line through there. So how does that help you? It gives you a sense of the nature of the relationship, the potential linear relationship between the two variables. Okay? And of course, this best fitting line has some nice properties. Average error is 0. Sum of squared errors is minimum. That's why it's the best fitting line. It may not be a great line, but it's the best fitting line. Okay, so that's what you're looking for there on the second printout. Then you're going to come down to the third printout. By the way, you could, if you want to put more than one printout on a page, that's fine with me. It saves you some paper. Okay, so this is printout number 3. It's just the correlation between the two variables. That's all it is, the correlation between the two variables. And there it is, just the one number of importance, correlation between the two variables. And of course, you're going to interpret that as how strong or how weak or how moderate the linear relationship is between the two variables. And you'll answer a question like that on the exam. But that's what you're looking for there. And then printout number 4. Now this one's the standard regression printout. Okay, make sure that you only have your one variable in the model. There's your independent variable. There's your dependent variable up here. Price is my dependent variable. Age is my independent variable. What are some important numbers that we look at on this printout? Well, the t-test on the beta 1. Now, how do I know which one's row represents beta 1? Beta 1's multiplied by age, therefore it's the age row. So it's that t value. There's the estimates of the betas. Both these are important. There's the estimate of the y-intercept, negative 192. Here's the estimate of the slope, of 10.4. If you want to form a confidence interval, you need the standard error of the estimate, so you need that number also, if you had to form a confidence interval. So those are some important numbers. What else? Well, the R-squared is important for evaluating practical utility. Standard deviation is important. That's this right here for evaluating, again, the practical utility. Now, I'm highlighting them here. You're not going to do this, right? Hey, if you want to get a second set of printouts for practice, highlight all you want on those to help you study and practice for the test. But of course, the printout you're bringing in, you're not going to have any marks like this on there. Yeah, those are the important numbers. Okay? And then finally, printout number 5. This is prediction intervals, confidence intervals. Of course, first, what did you set the independent variable at? What did you hold fixed? Well, here I held age fixed at 125. Am I okay there? Age of 125 years? Is that an okay value to pick? Yeah, because that's in the range. Remember, my range is like 108 to 190 or something like that. Yeah. It's a 95% confidence interval, so that's what the 95 means. And then remember, there's two intervals. There's prediction intervals and confidence. Prediction is on the left-hand side. And so you have the lower end point and the upper end point for the prediction interval. Then the other one's the confidence interval for the mean, so there's the lower end point for that one. And then the upper end point for that one. So these are all the important numbers that you're going to be focusing in on for your printouts. Okay? Now remember, I gave a demonstration on how to generate these printouts using the software. Go to lecture 9. If you forget, go to lecture 9. That's where I do the demo. And of course, you can always get help from the TAs to doing that too. And all of the instructions, points and clicks are written for you in the handout. Okay, so those are the 5 printouts. All right, now we're going to go do practice exam number 2. The one that's in the notes. Okay, that's the one I'm going to give you the answers to. And those answers are also posted for you. We're going to look at that here in a second on Canvas. There's also a second practice exam up on Canvas. I would hold off on that one. And kind of the way to study for this is, I would focus in on for the simple linear regression part, you're going to focus in on just your data. Okay, no, you don't need to look at any other one of those 4 data sets, just the one you pick. Okay, focus in on that. For multiple regression, good practice would be go to the textbook, find some of the problems involving multiple regression, and generate the printouts for those, and practice. Okay, so I would definitely do some other things. I don't want you to just look at the sample exam we're going to go over right now. Go to the class notes too. Look at the practical interpretations. They're all bolded for you there, and so. Just several ways you can study for this. But let's take a look at the practice exam, okay? The one that's in the class notes. The one I've given answers to. Okay? All right, so there's going to be 2 parts to your exam, just like on this practice exam. And part number 1 is going to involve your data set, the one you picked out, the simple linear regression data set that you picked out. The second part is going to involve a multiple regression situation, where I'm going to give you the story, describe the variables, and give you the printouts. Okay? So there are going to be some extra printouts on your exam, ones that you don't bring in with you. Those are going to correspond to the second part. All right, so you already know about the first part. You got the 5 printouts. Okay, now the second part, we got to read the story here and see what it says. Some company produces a brand of laundry detergent. We're investigating the factors that impact monthly demand. And so that's actually the dependent variable, monthly demand. A sample of 60 recent months. Let's highlight that for a second. A sample of 60 recent months. By the way, on this portion of the exam, you're welcome to write all over it and highlight it, okay? Because you're not going to see this until you actually get there. So that should tell you what your experimental unit is. A sample of 60-somethings. Oh, months, okay? And then what's going to be measured for each month? Well, first of all, the demand. Turns out that's going to be our dependent variable when you read the rest of the story. Also, price is another variable measured. And finally, advertising expenditure. Okay, so those are the variables being measured. And then look what it says next. The manager used the software to build a regression model for predicting monthly demand. So that's how I knew the demand was the dependent variable, because it says it right there in the next line. Okay, so now we know what the dependent variable is. That's demand. And then, of course, that means the other 2 variables are our independent variables, our x's. And price being one of them, and advertising expenditure being the other. Okay, notice I do give you a formula for finding a confidence interval in regression, if you have to use that. All right, so then you're going to get some printouts. All right, and I'm just picking up, your printouts are numbered 1, 2, 3, 4, and 5. Okay, so then I'm picking up from there, okay, number 6, number 7, and so on. Let's just take a look at each one of these printouts and see what information we're getting in each one of these. Printout number 6, descriptive statistics for each of the variables, demand, price, and advertising expenditure. We're given the mean, we're given the standard deviation. We've seen that before, but how's this going to help us? Wait, what about minimum and maximum? Oh, this is kind of an easier way to see what the range is on the x's. Remember, and that's important, right? For prediction purposes, trying to figure out what value of x we should substitute into the prediction equation to make reliable predictions. So price being one of the variables. Here's the range on price. $3.55. Oops, that's too. I don't know why it's wanting to highlight more than I want it to. $3.55 to $3.90. So I shouldn't be trying to predict the demand for a month where the price is set at, say, $4, that's outside the range, or when the price is set at $2, that's outside the range. I need to restrict my range, that my value of that X between 3.55 and 3.9. And look, for advertising expenditure, these are in 100,000 bottles, $100,000. That range is from 5.25 to 7.25. So I better stick with picking values of advertising expenditure between those two numbers. So that's how important that printout helps us, kind of simplifies our job. Instead of glancing down a whole long list of numbers, we can look at the ranges. So those certainly will help us with the last step. All right, the next printout, print number 7. Well, this is a linear regression printout, only for multiple regression. How do I know it's multiple regression? And how do I know what the dependent variable is? Well, look up here. There's demand at the top. There's your dependent variable. How do I know it's multiple regression? Because there's 2 independent variables. There's price and there's advertising expenditure, right? That's how I know it's multiple regression. And of course, there's t-tests on each one of those, and there's beta estimates and so on. And the coefficients give us the beta estimates. So I'm just going to highlight that. The beta estimates right below. There's all the beta estimates right below. What other numbers are important? Well, kind of think of the flow chart. To evaluate the model, you always start off, the game plan is always to start off with what? To evaluate a model statistically. F-test. Here's the p-value for the F-test at the bottom. All right? So that'll get at the statistical utility of the model. And then once we figure out that the model is statistically useful, we want to evaluate it from a practical standpoint. And we, of course, have the 2 numbers we look at from a practical standpoint. Now remember, in multiple regression, you look at adjusted R squared. And you always look at the standard deviation. So I highlighted those numbers. So again, just making sure we understand from a printout standpoint, where are the important numbers on the printout? All right, so that's printout number 7. Then we go to printout number 8. This is confidence intervals, prediction intervals. We kind of already looked at this. So the same things I highlighted before, I can highlight again. I'll just highlight one of these things. Okay. At the bottom, it gives you the values of the x's that were specified to generate the 2 intervals. You know where the lower and upper bound are. You know which one's the prediction interval, which one's the confidence interval. Prediction interval to the left, confidence interval to the right. Same as before, so that's nothing different. But notice now I'm setting price at 3.75, advertising expenditure at 6. You should go back and look at those ranges and make sure that they both fall within the ranges. They do. But check to make sure. Okay? And so you get your intervals. Your left-hand side prediction interval and your right-hand side confidence interval. And then finally, the 9th printout, you can see it's another regression, demand being the dependent variable. Look at the variables. We've got price in there, advertising expenditure, but we also have price times advertising expenditure. Oh, it's an interaction model. It's an interaction model. It's got the interaction term in there. And of course, I'm not going to highlight any more stuff on here because you already know what to highlight. Same as before. The global F-test, the estimates of the betas, the adjusted R squared, the standard deviation. So same things we highlighted in a previous printout we highlight here. And of course, now I'll highlight one extra thing because the t-test on the interaction term is now important. Right? So that p-value now becomes important to evaluate because you'd want to know, is there evidence of interaction? So everything we highlighted before plus this. Right? Okay, so there's the printouts for the multiple regression side of things. So now let's take a look at the questions. Of course, we start with part 1, your data. And notice I put in red there, your answer is going to be different based on the choice of your data set. The data set I'm looking at is not even one of your choices. Okay? So, experimental unit. Hey, you knew I was going to ask you this. I'll continue to ask it all throughout this whole semester because it's really important, especially when it comes time for you to collect your own data. If you don't know your experimental unit, you'll never be able to get your own data. Okay, here you've already had your data collected for you. So what is your experimental unit? Well, I'm looking at mine. Okay, I've collected data on, I forget how many grandfather clocks there were. I think 32. 32 grandfather clocks sold at auction. So my experimental unit is a grandfather clock sold at auction. Again, you can figure that out based on what the sample represents. I've got a sample of 32 clocks sold at auction. Therefore, the clock that's sold at an auction is the experimental unit. You look at your data set and see what you sampled. A sample of things. I'm not going to give anything away there. It's a sample of things. And by the way, you could figure this all out ahead of time. So you should know these answers coming into the test. Should be easy. The dependent variable for me is going to be my auction price. And of course, you have to give the units of measurement. Mine's dollars. The independent variable for me is the age of the clock. And so I have to give that. And look, I'm telling you what these are for you. Go look at, I'm just going to switch over real quickly to the project data printout. And when I list the data sets, right next to it, I tell you what Y is and I tell you what X is, right? So you already have these answers. Now look, you can't bring in this with you, okay? You got to remember this, all right? You can't don't bring any additional information in, just your 5 printouts. So you can't bring in this page that tells you all this stuff, but you have it right on there. It's there. So you should have those answers. Okay, now we get to the multiple choice. Second question. Consider the hypothesized straight line model. Okay, doing simple linear regression. All right, good. We know we're doing that. And we're going to look at the least squares line shown on the scatter plot printout number 2. So you're going to go back and look at your printout number 2 and that line that's shown on there. I've showed it to you earlier. I'm not going to show it again. And it says, which of the following is not a property of the line? Not a property of the line. My advice to you here is when you see a multiple choice like this is kind of try to think of the answer without looking at the 5 answers. It's not that I'm trying to trip you up with the 4 wrong answers. I'll be honest with you. I don't make up the 4 wrong answers. Other students do. You guys make up the 4 wrong answers. I just happen to put them on the test. So they're going to sound good to you. Okay? But it kind of not looking at the answers, think about, oh, the least squares line, the best fitting line has 2 properties. One property is that it has an average error 0. A second property is that the sum of squared errors is minimum. It's the best fitting line through the data. It has a certain slope. Okay, let's take a look. We'll have to read all of them. The line yields a sum of squared errors that is minimum. Well, that's a property, so that's not the correct answer. That's not a property. The line yields an average error 0. Oh, that's a property, so that's not the correct answer. It is considered the best fitting line. Well, it actually is, so that's a property. That's not their answer. I'm going to skip D. The line has a positive slope. Okay, if you looked at my line, it did. It had a positive slope. Okay, so that's not the right answer because it is true. And the part that says it is the true line of means for the dependent. No, it's not the true line of means. Nobody knows the true line of means. We're estimating it. So that's the correct answer because it's not a property. Okay? Number 3 says practically interpret the value of the correlation coefficient. So you have to find that. And notice again, I'm having spots for you to put the printout number in.
What if it's a negative line? Does that even matter?
Okay, the question is, good question. Okay, the question is, what if the answer E, well, what if you have a line that has a negative slope? Because you could, all right? Then I wouldn't be able to ask this question of you, okay? Actually, what happened here was for the data sets that I gave the students at this time when I gave this exam, there were no negative lines. They were all positive, so I knew that. Okay, but I would have to be smart enough to ask it in the right way. Okay. Yeah, okay, so number 3, the correlation coefficient. Remember, there's spots for printout numbers. Don't leave those out. Okay, those are easy points to get. All right, so that's coming from printout number 3, and my correlation was like a 0.73 positive. If you go back and look at my printout, it was a 0.73 positive. And so how do I interpret that? Well, because it's correlation, you have to talk about linear relationships between the variables. You also have to look at the strength of the linear relationship. All right, is it close to 1 or not? And you also have to talk about what direction, positive or negative. Okay, so you can see this is positive, so evidence of positive, linear, and then I put strong / moderate because it's kind of like in between strong and moderate. And then I also put the variables in the words of the problem. So remember, all your interpretations are going to be practical, putting it in the words of the problem. So you look at your correlation coefficient and you then write out what your answer is. Number 4, practically interpret the y-intercept of the line. Again, printout number. If you go look at my printout, it's the y-intercept is a negative 192. And how do I interpret practically? Well, the first thing you have to figure out is look at your value of x Does it make any sense to substitute x equal to 0 into the prediction equation? If it makes sense, then this would be actually the predicted value of y for that x value. My x is age of a clock. No, it makes no sense for me to substitute x equal to 0 into the equation to predict the price. Who cares about the price of a clock if the age is 0? Nobody. It's nonsensical. Therefore, I'm going to say no practical interpretation. I'm going to give the reason why, because age equal to 0 is also nonsensical. You have to figure out whether the 0 value for your x makes sense and also is within the range of the sample data too. That's why it's important to look at that. And then maybe you would have a practical interpretation, and it would be the predicted value of y. But if not, not practical. So take a look at it for your data set. And again, you should have all these answers done ahead of time. In your head. You should know what they are. Because you know your data set and you have your printouts. Okay, number 5. Find and practically interpret an approximate 95% confidence interval for the slope. Again, you need a printout number. This is going to come out from printout number 4. Now, what do we need? Well, I gave you a formula for a confidence interval. You take the estimated beta, you add and subtract 2 times the standard error. I gave you that on the front of your exam. So you simply need to substitute in what the betas are. My slope is 10.5 and my standard error is 1.8. So if you do the math, you get a range from like 7 to 14. Look, if you make a math error here, don't worry. I'm not going to hold you responsible for that. Just show me your work. You're fine. So it's around 7 to 14. Now, how do I interpret it? That's more important. Well, this is a slope. A slope is interpreted as the change in y for every 1 unit increase in x. And because it's a confidence interval, I'll start off with the phrase I'm 95% confident. So I start off with that, and then I get into the change in y. Okay, well that's, in my case, for every 1 year increase in age. There's my change in y. I'm sorry, not change in y, change in x. There's the change in x, in the words of the problem, for every 1 year increase in age. And then the slope represents the change in y. So then I have to say price, and I say increases because it's positive, increases between the two numbers. I said increases because I have all the numbers in the interval that are positive. What if all these numbers in the interval were negative? What would change in this interpretation? What if all the numbers in the interval were negative? What would change? Change one word. Which one? Instead of price increases, it would be price decreases. Yep. What if one of the numbers was negative and one of the numbers was positive? You can't tell. It could decrease as much as $7 or increase as much as 14. You don't know whether it's increasing or decreasing. Okay, next one's a fill in the blanks. It says, in theory, the phrase 95% confident in the above interval implies that in repeated sampling, 95% of all blank will contain the true blank. So this is kind of, look, you know I'm going to ask you this question. Again, I told you that in the first test. I said, I'm always going to ask you about what the phrase 95% confidence means theoretically. I did it on the first test. Here I'm asking it to you also on this test. I'll ask it to you on the third test. I'll ask it to you on the final. Okay, it's an important concept. I want to make sure we get it. Hopefully by the end of the semester we'll all get it right. I'll ask it in different forms. Here's a fill in the blank. Okay, so what does the phrase 95% confident mean? Well, remember, the only way to make sense of it is you have to generate more than one interval. You cannot talk about just one interval. There's got to be a whole lot of intervals that you look at theoretically. And so and then you know that of all those intervals, 95% of them are going to contain the true parameter of interest. So now what do I fill in? Well, 95% of all similarly constructed intervals will contain the true what? Well, whatever the parameter of interest is. It's not always a mean. Okay, in fact, on the first test, it was a proportion. Here, on the second test, we're doing a confidence interval for the slope. So it's the slope. Will contain the true slope. Okay? Number 7, provide the following elements for a test to determine y is linearly related to x in this simple linear regression model. Okay, you have to specify HO and HA. HO is always the beta coefficient of the slope equal to 0. HA is the beta either non-zero or less than or greater than. It all depends on what you want to test. I'm just asking whether y is linearly related. I'm not specifying a direction, so therefore you could put a not equal to sign there and you'd be right. If I said testing whether y is positively linear related, then you would put beta 1 greater than 0. If I asked you whether y was negatively linearly related, then it would be beta 1 less than 0. Depends on what I ask you. Of course, you pick an alpha. That's your choice. I'm going to pick 0.05. You find the right p-value from the printout. That's coming from printout number 4. Okay, I highlighted it for you earlier. And then, of course, alpha greater than P, remember the rule. Alpha greater than P, reject the null hypothesis in favor of the alternative. Now write the alternative in the words of the problem. Okay, there's sufficient evidence of a linear relationship between, and the key words of the problem, price and age. All right. And number 8, it's a true false. For the inferences derived from the above test to be valid, the regression errors must be independent and normally distributed with a mean of 0 and a constant variance. Well, yeah, those are the 4 assumptions. That's true. And you can see that's the kinds of things I can ask you about in part number 1. Okay, so you should be ready for anything there. Okay, and hopefully you ace that part of the test. It won't be quite 50% of the test, a little bit less, but it's nearly 50%. Oops. All right, now we go to part 2. Now remember, we already talked about what the data was. If you go back and you remember, the data was we're trying to model the demand for some product, for a laundry detergent, based on the price of the product and also based on how much we spend on advertising expenditure. Okay, so, and then now I ask you something about it. Okay, number 9, consider the hypothesized first order multiple regression model. So I'm talking about that first multiple regression model. And you can see the format of it. Just has the 2 x's in there. Y is demand, x1 is price, x2 is advertising expenditure. It says give the least squares prediction equation. Well, those are just the estimates of the betas right from the printout. Now this is coming from printout number 8. No, it's not. Why did I put printout number 8 there? Is it? Let's go back and look. I forget what the printout number. I want to make sure I got it right for you. No, it's not number 8. It's number 7. Yeah, number 7. That's my bad. Sorry about that. Make that correction, would you please? So it's printout number 7. We're getting the estimate. There's our estimates of the betas right here. Okay. The 4.78 for the y-intercept, the negative 0.54 for the beta multiplied by price, and the 0.86 for the beta multiplied by advertising expenditure right here under coefficient. Yeah, so that's printout 7, so I got to change that. Didn't think that sounded right when I said it to you. So this is really printout 7. That should be a 7. Okay, and there's our equation. It's the estimated betas now. Okay, notice I have put in the x1 and x2 in the right spots. Okay, so then fill in the blanks. So I'll leave out the answer right now. In the first order model, for every blank in price, we estimate demand to blank holding blank constant. Ooh, what the heck is that asking us? For every something in price, we estimate demand. Okay, I'm putting it in the words of the problem. By using the words price and demand, I think to diagnose this, to figure this out, change it back to generic symbols. So price is what variable? Well, that's an x. That's x1. So I'm doing something to x, and then we estimate demand. Well, demand is y. Oh, that sounds like a slope. That sounds like a slope, right? You change x1, increase it by 1 unit, and see what happens to y. Okay, so now I can fill in the blank. So I want to increase price by 1 unit. Well, if you go back and you look at the units of measurement on price, it's dollars, so for every $1 increase in price. And then we estimate demand to, well, now you have to look at the beta associated with price, and it's a negative 0.55. That means demand is going to go down. That's a negative number. So demand is going to decrease. By how much? The 0.55, and then I have the units of measurement on x1, which is 100,000 bottles. I'm sorry, units of measurement on y, 100,000 bottles. So it's a unit of measurement on y. And then I have to hold the other variable fixed, right? Because this is multiple regression. What's the other variable? Advertising expenditure. So that's how you have to look at that problem. Okay? Number 11, provide the following elements for a test of the overall adequacy of the first order model. This is the global F test. It's a global F test. So obviously HO is the betas in our model simultaneously equal to 0, the 2 betas, beta 1 and beta 2. I'm letting you pick alpha, so I'll pick 0.05. HA is at least 1 beta, not 0. That's always the case for multiple regression. P-values right from the printout, and now I have the right printout, number 7. And the p-value is 0.002. Okay, so what's our conclusion? Well, alpha greater than P, reject HO in favor of HA. Our model does have statistical utility, so, and I say that since alpha is greater than P, there is sufficient evidence to say that the monthly demand Y is linearly related to selling price and advertising expenditure. Or I could say, either one's acceptable to me. You could say that the first order model with selling price X1 and advertising expenditure X2 is statistically useful for predicting demand Y. So as long as you get your words of the problem right, you got this answer. So we have a statistically useful model. Number 12 says give a practical interpretation of the 95% prediction interval for Y using the first order model. Now this is going to come from printout number 8, so I do have the printout number correct there. And remember, I highlighted the values of the x's on that printout for you a little bit earlier. And it was x1 equal to 3.75 and x2 equal to 6. And then now which side do we want, which interval, the one on the left or the one on the right? Well, this is a prediction interval, so it's the one on the left. And that range went from a 7.2 to an 8.6. If you go back and look at that printout, you'll see that. Okay, 7.2 to 8.6. And so now we have to make the practical interpretation. Well, this is a confidence interval, so you go ahead and state you're 95% confident. And then what I like to do next is specify the values of the x's. Okay, so, and remember, being a prediction interval, you have to get your experimental unit in there also. So for a single experimental unit with these values of the x's, so that's what comes next. That the demand for a month when selling price is $3.75, that's one of the x's, and advertising expenditure is $600,000, that's the other x. So for a month that have those values of the x's, demand is going to fall between the 7.2 and the 8.6, but now you need your units of measurement on demand. Okay, so there's a lot of units of measurement going on here, and you have to remember which ones go with which. Okay, why do I say price $3.75? Why dollars? Because the units of measurement on price is dollars. Why do I say advertising expenditure is $600,000? Because units of measurement on X2 advertising expenditure is $100,000. And why do I say demand falls between 7.2 and 8.6, 100,000 bottles? Because demand is measured in 100,000 bottles. You have to keep straight your units of measurement. Okay? All right, number 13. Give the standard deviation for the model and then practically interpret it. Of course, we know this interpretation will be the same for all models. You have to change the words of the problem. That's again coming from printout number 7. I highlighted it for you. It was 0.35. You double that, you get 0.7. Okay, and now this is not a confidence interval, so you can't use the word confidence here. But what you can say is about 95% of the actual demand values are going to fall within 0.7 units of measurement of their predicted. So now I put the units of measurement in. So about 95% of the actual monthly demand values will fall within 0.7 100,000 bottles, because that's units of measurement, of their predicted values using the first order model that has price and advertising expenditure. And you go back and look at all the interpretations that we made on all the different models in class for this particular statistic, and they all look the same. You're just changing the units of measurement and the variables, that's all. Number 14 says give the adjusted R squared for the model and practically interpret that value. Again, this is coming from print number 7. I highlighted it for you a little bit earlier. It's about a 0.677. And so remember, you interpret this just like R squared. It's proportion of variation explained by the model. So about 68% of the sample variation in Y, monthly demand, can be explained by the model, first order model that has X1 and X2 in it. Again, this interpretation, go back and look at all the ones we made in class. Same, except for the units of measurement and the different variables, but it looks the same. Number 15 says, do you recommend using the model in practice, or would you recommend searching for a better model? And there's some choices. Now, how do you make this decision? Well, first, you're never going to use a model that's not statistically useful. So check that first. Well, this model was statistically useful. We did it with the global F test. So that's good. But is it practically useful? Because you're not going to use a model that's not practically useful either. Well, you have to judge the magnitude of the R squared statistic. Is it high enough for you? This was about 68%. And you also have to judge the magnitude of the standard deviation, the 2S. Is it small enough for you to be happy? What was the standard deviation? I forget. 0.7. So predicting demand within 0.7 100,000. So you have to make that judgment call. Now, I circled 2 answers here because they're both acceptable in this application, because your opinion might be different than mine. Okay, notice that in both, the global F test is significant. Okay, so we know that the model is statistically useful. But in answer A, If you think like this, it's because you believe adjusted R squared is high enough in your opinion and the 2s is small enough in your opinion. That's why you're circling A. But if you don't like the R squared, if it's not high enough in your opinion, and you don't, or you don't like twice the standard deviation, it's not small enough in your opinion, then you would pick D. Look for a better model. Although the global f-test is significant, you don't like R squared, you don't like 2s. Okay, none of the other answers can be right. They don't make any sense. Okay, that's number 15. And then we'll finish up on the last page. Number 16 says, give a practical interpretation of the phrase price and advertising expenditure interact. What does that mean when we say that the two variables interact? Remember, price is x1, advertising expenditure is x2. So the phrase only involves x1 and x2. But by using the word interact, that implies a model, and the model needs y. So just to help you with this, you can't just talk about x1 and x2 to get this answer right. You have to involve y, because it's a model that has the interaction term in it. And what that means is that the relationship between the y and one of those x's depends on the other x. Think of the picture that I drew you with the slopes being different. The slope of the relationship between y and one x is different depending on the other x. You could write it like that if you wanted. And so I've written out the relationship between demand, which is y, and price, which is x1, depends on advertising expenditure, which is x2. And you could reverse the roles of the two x's, that's fine. So it's just a little helpful hint that when you just see this, you're kind of tempted to only put in words involving x1 and x2, but the word interact means model, and model needs y, and so you have to get y in there too. Okay? All right, number 17, it says, conduct a test to determine if price and advertising expenditure interact. Well, now you need the interaction model to do this. That's coming from printout number 9. Remember, we looked at that. And it's the t-test on that interaction term. I highlighted that one for you. And so the test that we're conducting is that the beta 3 term, the interaction term, is 0 versus non-zero in HA. You pick alpha. I picked 0.05. P-value from the printout was 0.1554. I highlighted that for you a little bit earlier. You saw me do it. Okay, that's from printout number 9. So now the alpha does not exceed the p-value. It's a fail to reject HO, right? So now I'm saying there's insufficient evidence of interaction between price and advertising expenditure. And what does that mean to say that there's insufficient evidence of interaction between price and advertising expenditure? It's saying that there's insufficient evidence to say that the relationship between demand and price depends on advertising. Again, I put the word interaction in words of the problem. But we don't have any evidence to say that that's the case. Insufficient evidence to say that the relationship between demand and price depends on advertising. It looks like the slopes don't change. That's number 17. That's the last one. Okay, so you see the form of the test. We can get off that now. You see the form of the test. And so what's going to happen is that you kind of already know what kinds of questions I'm going to ask you about when it comes to part number 1. All right, you know that. Those should be gimmies. Okay? If they're not gimmies, you're not preparing. Okay, so part number 1 should be gimme. I may not ask the questions exactly the same way, but if you can answer these questions on this test for your partner, for your data, you're going to get the ones on the one I'm going to ask you. Okay, so part number 1 is gimme. Okay, part number 2, that'll depend on the story. Okay, so examine the story. But again, if you know the two kinds of multiple regression models, so look at the story. Oh, the story's way at the top, sorry. Let's look at the story. All right, make sure you know what the x's are. Make sure you know what the y is, what your units of measurement are. That's really important. Words of the problem. Don't get dinged, -1 here, -1 there for not putting in units of measurement. Okay, make sure you put those in there. That's important. Make sure you recognize the printouts. That's important. Okay, all that's important. All that comes together. If you want to, you could generate these same printouts that I'm showing you here for the multiple regression for a different problem in your textbook. There's several multiple regression data sets in the textbook that involve 2 x's. Go get that data set, run it through statistics, generate these extra printouts, practice on answering the questions with the different data set. That'll really prepare you for this test. Okay? Anyway, some helpful hints. Now, when I come back next week on the Monday lecture, the Monday, Tuesday lecture, that won't cover stuff on your exam. I'll see everybody for the test on Wednesday and Thursday, so see you then.